Welcome, everyone. Thank you for joining the latest Opta Live webinar, which is our replacement for the OTE Conference and Trade Show. And thank you to Proterra for sponsoring this event, a very timely topic and of great interest to members, given the number of people we have registered today. So with that, I'm going to turn it over to Mike Bismarck.
Thanks, Karen, and thanks everyone for joining us today. We appreciate the time, and we look forward to chatting to you and taking some questions. Mike Bismarck, Regional Sales Director for Proterra. So many of you do know me from the many interactions over the years and the phone calls, and I'm going to have Mr. James Hall, our Manager of Training, with us, who I'll introduce momentarily as well. We're going to talk a little bit about battery electric bus familiarization and getting the workforce ready and workforce development, which is obviously a key term in the industry. So we'll move right along. But before we do that, we're obviously going to talk a little bit about both chargers and buses from a training perspective. So Proterra does offer both those. I've got a slide or two on each just to talk about that. But wanted to start first by, of course, a big thanks to all the transit workers, employees, support staff, et cetera, that continue to keep transit moving as we inch our way out of this pandemic and get a little bit closer to normalcy. So thank you very much for all your efforts and continuing to do that. So just a little bit about Proterra before we get started. Obviously, many of you know, and again, I've talked to most of you. Feel free to call me, talk to me offline. But Proterra sold over 1,000 buses, multiple different partnerships with our batteries and our Proterra power team. Over 50 megawatts of chargers installed, 30 million service miles that continue to help reimagine and redevelop our vehicle based on that. But really what I wanted to say with this slide too is that it means that we've been delivering and continue to enhance our training for a long time as well, which James is going to speak to, and he's now the manager of that program and is going to lead us through some slides today. Our current product is that ZX5 bus, and again, if any of you that have been on multiple of the conferences, we've talked about this, but the ZX5 is our longest range bus in the industry for a 40-foot. Is available with up to 675 kilowatts of onboard energy storage. That is the bus that's been deployed in Edmonton and that will be launching next week in Banff, Alberta as well. TTC has the prior generation, which was our Catalyst 40-foot bus as well, so you're able to see that bus there. Multiple changes and things that have been refined on this vehicle. Again, I don't want to jump into it all here. We're here for some training, but just really to talk that we do offer both buses, chargers, and then a little bit about our partnerships and our best-in-class battery technology. We continue to evolve there as well. And these are some of the partnerships and OEMs that we've partnered with that are using our batteries. And the optimal one there on the bottom left second row is the low floor cutaway shuttle bus. That's going to be available in the Canadian market, order taking towards Q4. It's going to be handled by dealers in Canada, CityView on the East Coast and Dynamic on the West Coast. So some of you may be interested in that. One of our more recent partnerings was with Komatsu and electrifying their excavators. So yeah, lots of things going on with Proterra, the batteries. We've opened a new battery plant in LA to sort of support the rapid expansion of our battery deployment and partnerships. And then just on the charger front, we've got everything from 75 kilowatt all the way up to 1.5 megawatt chargers. And again, we're going to talk about some charger safety and things to look at with chargers, but just wanted to sort of show an example. This is our new 1.5 megawatt, which can charge up to 40 buses and have 20 dispensers with multiple dispensers on it. So on the left, you see the footprint of that 1.5 megawatt, which again, from a form factor and installation standpoint, is very advantageous as opposed to putting in 20 individual chargers with multi-dispensing, et cetera. In the middle is the dispenser. Like any of our chargers can be up to 500 feet away from the actual charger itself. And then you see obviously the dispenser plug on the right-hand side. So really just wanted to give you a brief overview of that. And these are some in-action photos, I guess. On the left-hand side is the 1.5 megawatt at our South Carolina factory, where we use it to commission buses for overhead charging when they come off the line, but it gives you an idea of the scale versus the bus. And then on the right-hand side is the ZX5 bus in the Edmonton garage, where they've used the overhead in-depot charging strategy. So just wanted to show you a couple pictures of what that looks like there. But again, feel free to reach out to me for any of those things. And without further ado, I am going to turn it over to Mr. James Hall. And James, I'll let you introduce yourself, and we'll get right into it.
Thanks, Mike. Thanks everyone for being here, and Opta, thank you for having us. We really appreciate the time. I look forward to the conversation with everyone. And to that point, before I actually get into my introduction here, feel free to ask any questions in the chat. Mike's going to go through, and as we transition between topics, he's going to take most of those questions and send them our way. So if it's something that he can answer or I can answer along the way, we'll pair together and try and get those answered to the best of our ability. If there's something that we can't answer live, please know that we're going to take that away. We've got your contact information, so we are going to follow through and make sure that we get you the right answer that you're looking for. So as Mike said, my name is James Hall. I'm the manager of training here at Proterra. I've been with the company for 3 years, and I have a bit of a background in transit, as you can see. So over a decade's worth of experience with automotive applications and transit applications. Toyota, WMATA, and Proterra are really the biggest places that I had spent time. I'm currently the co-chair of the West Coast Center of Excellence Advisory Board, where we are working to build out training for most of North America, and really just kind of set the stage, if you will, for not only battery electric buses, but zero emission vehicles, zero emission buses in transit. I'm also an advisor to the Transportation Learning Center, as well as today's class. And then I sit as an active member of the California Transit Association. Next slide. So today we're going to discuss 3 major topics. So we have 3 specific objectives that we're looking to accomplish. First, I'd like to make sure that everybody's prepared for success as we transition towards battery electric buses. We're going to discuss things such as prerequisites. So what are the skills that technicians should have prior to actually starting to work on a bus, things that you should look for in technicians, training programs that are associated with bringing them up to speed and getting them comfortable, and then identifying champions in your workforce. We're also going to examine high voltage safety and the associated tools and best safety practices, things such as PPE and then precision measuring instruments, and how they're different on battery electric buses versus internal combustion engines. We're going to take a look at and introduce learners to charging infrastructure and the associated safety. So types of charging, whether it be the different SAE standards, so J3105 and J1772, for example. And then we're also going to take a look at generic lockout tagout procedures. I know that most people on this webinar aren't exactly technicians, but understanding the lockout tagout procedures and how it's going to relate to your workforce is really important. It will drive your understanding as well as their understanding and the ideas of what PPE you're going to need and how you're going to best support their success. Next slide. All right, so we're going to kick it off with the preparing technicians for BEBs. Again, taking a look at the skills, training, and identifying the champions. So to start, their prerequisite skills. Obviously, one of the biggest points here is that this is a battery electric bus. So electrical theory is going to be one of the most important topics that your technicians are going to need to understand. The basics being things like voltage, which is your electrical potential or the pressure to drive the circuit. Current, which is the flow of that electrical energy. You jumped back a little bit there, Mike.
Yeah, sorry, James. Yeah.
No worries.
There you go.
There we go. All right. So resistance is the next topic here, and that's going to be the hindrance to flow. If we're looking at this from a mechanical theory standpoint, this would be something similar to friction. And then they're also going to need to understand Ohm's law. So V equals I times R. And for those of us who have not had to break out the algebra in a number of years, we may have to brush up a little bit because if you don't understand the calculation of how to get voltage equals the current flow or multiplied by the resistance here, you need to be able to solve for V, for example. So if we don't actually have that voltage, how do I multiply the current, the resistance, and vice versa? Another important topic here that also needs to be included is the hydraulic and pneumatic theory. So, for example, fluid power is going to be the hydraulic side of things, basically exerting a force on fluids that are contained inside of a single enclosure. It should transmit that same force on the other end. Now, if we're talking about pneumatics, that force is reduced, right? So we don't have as much pressure that can be exerted on the opposite end. But both of these are extremely important theories to understand because with our battery electric buses, just like your transit buses, internal combustion engine and hydraulic, there are still pneumatics and hydraulics that come into play. So Understanding that theory is going to be important, and it's going to be just as big of a drive towards success here. Another one to make sure that technicians at least have a grasp on is Pascal's law. So again, that is exerting the same amount of pressure in a closed hydraulic circuit on both ends, and being able to calculate that. And it doesn't have to be, a long calculation. Just simply, if I put 5 pounds of pressure on this end, here's 5 pounds of pressure on the opposite end. Next slide. So again, going into the prerequisite skills, one of the most important topics, and in this slide, you can see high voltage safety and PPE are two extremely important skills that technicians need to understand. So starting off with high voltage safety, AC versus DC circuits, and understanding how to safely protect yourself and others against those. So essentially, what is the difference in operating principles or the electrical theory of an AC circuit or alternating current circuit versus a DC circuit, which is your direct current circuit? Adding to that, protecting others. So high voltage safety does include things like lockout, tagout. And when you're performing lockout, tagout, all OEMs, all manufacturers, at least of BEBs, but also in almost every aspect that I've ever come in contact with, lockout, tagout does require a safety observer. When it comes to electric vehicles and electric lockout, tagout, OEM procedures always require an additional safety observer. So knowing how to protect yourself and others means I know how to protect myself when doing the lockout, tagout, but I also know how to watch somebody else perform that lockout, tagout and make sure that they're safely following along with the normal procedures. It's extremely important here because we want everybody to go home safely. Just as importantly to this, AC is known as the more dangerous type of circuitry or of current, mostly because of the way that the frequency interacts with your muscles. So if you were to inadvertently come into contact with an AC circuit, your muscles will spasm, and it makes it more difficult for you to remove yourself from that circuit. We want to make sure that the technicians understand when working with AC, there is an inherent risk that comes along with that, and how to safely work around those. DC circuits aren't necessarily less dangerous per se, but there is a different type of risk that comes along with it. As I mentioned, lockout, tagout procedures. So understanding why lockout, tagout is important, and respecting the rules of locking out a device, be it mechanical or electrical. So I like to use the example of when you're looking at large machinery, instead of just speaking to electrical lockout, tagout here, when you are looking at a large hydraulic press, for example, if there is someone working inside of that press, there's a reason it's locked out. You don't know if there's a person inside of that press repairing or fixing some sort of hydraulics inside. If you were to go through and remove a lockout device because you were not trained properly on lockout, tagout, or you do not respect lockout, tagout, there is obviously a huge risk that's associated with that. So making sure that technicians understand the lockout, tagout procedures, understanding the risks associated with that, but then also knowing how to respect that is extremely important as well there. The next topic here is PPE. So different levels of PPE may be required for different tasks. So knowing how to find the information on the required PPE for each task, and that different OEMs may require different levels of PPE based on their designs, is something that technicians need to understand as well. For example, Proterra, we require simply shock hazard PPE, whereas other OEMs may require high voltage arc flash hazard, as we're showing here. So there are different levels of PPE required per OEMs, but we can go even a step further with our shock hazard PPE. Once you have confirmed that voltage is absent, you verify that there is no presence of voltage in any of these circuits, you are able to, in most circumstances, step down the level of PPE. So let's say you are wearing your EH-rated safety shoes, high voltage rubber gloves with other overlays, and your safety glasses. That's all that's required for shock hazard. Once I've confirmed that there is no voltage present, I can take those rubber gloves off and do the work that needs to be done, up until the point where I'm maybe testing again for voltage, where I then may have to put on a different level of PPE. So those are the types of varying levels that we're discussing at this point here. Also, understanding how to properly care for and inspect PPE is just as important. So there are different ways to test your rubber gloves. And since we're on that topic, I'll continue with that. You're always going to inspect for any tears, cuts, nicks, anything that would indicate a breakdown of isolation between you and that circuit. But more importantly, understanding how to inspect the tested dates on the rubber gloves. There is a 6-month interval on replacement. So they have a 1-year shelf life, which is also just as confusing. But the 6-month interval is the moment that they went into work, if you will. So now that this technician has been issued these rubber gloves from the date that they have started using them, that is the date, that is 6 months prior to the date that they need to replace them. So 6 months later, they need to either replace or have them inspected. Our experience typically is companies like Grainger or Fastenal will offer some sort of exchange program. So setting something like that up ahead of time is basically setting yourself up for success. You're guaranteed to have replacement gloves ready to go. If there's a long lead time, you can get that order in ahead of time as well. And then on top of that, your technicians will feel just as comfortable because they will know that they have the most up-to-date safe gloves possible. So it's extremely important to get those. Next slide, Mike. So another prerequisite skill to add here is, it seems kind of obvious for a technician, but I just want to make sure we emphasize this: proper use of hand tools. There's always going to be the correct tool for the job at hand. And it's important to point this out. One of the ways that I like to explain this is, as we're showing here, there is an adjustable wrench that's pictured off on the left-hand side. Just because an adjustable wrench will fit a fastener that you need to remove or tighten doesn't necessarily make it the right tool for the job. So in some cases, you may need to use a special socket or an insulated tool, for example, especially when tightening things in high voltage circuitry. So if you have bus bars and you were to use an adjustable wrench instead of a socket, and then you accidentally start to score the bus bar itself, there can be an added level of resistance or what becomes a hot spot on that bus bar. So just because the tool worked doesn't necessarily mean that it was the right tool for the job. You actually caused more work for yourself here. Just to point out, it is important to note that some OEMs do include, we take the initiative, at least in Proterra, we work really hard on this one, to include all of the proper tools and PPE right at the start of your work procedure. So these are all the tools that you're going to need prior to you beginning work on anything. This really sets the technician up for success, but it also sets the company up for success as well. So no matter what you do, you know exactly what you should have on hand. And you're more likely, if you have that time to prepare, you're more likely to actually use the right tools and equipment anyway. Another one is your DMM, or digital multimeter, and DVOM, or digital voltage ohm meter. Same idea here, same meaning, different terminology, but the acronyms are interchangeable. There needs to be proficiency with technicians here. Stateside, I can say that the level of proficiency is not exactly where we would like it. I'd say anywhere between 10 and 25% of technicians in transit really feel comfortable with using their digital multimeter. Now, my experience with Canada is that number is actually a bit higher, but we still need to make sure that we drive that home, that BEB technicians are comfortable using their digital multimeters. Electricity, like is mentioned here, once properly contained, is neither seen nor heard in a circuit. And I know that there are some people that will point out, well, I can hear the hum of a transformer. And we'll go into the physics on a separate conversation, but in essence, you're not actually hearing the electricity here. It is important to point out that for you to properly troubleshoot, maintain, measure the electricity in a circuit, you're going to need to know how to use your digital multimeter. It's also just as important to point out that you should not rely on voltage tester pens, at least on BEBs, because the majority of everything that you're working on is actually DC voltage. We'll start with that. So it is not the proper tool to test for voltage, but even further to that point, even the AC voltage that is on this bus, most of those tester pens are not rated for that voltage. So even if we're looking at an AC voltage of 230, most of those tester pens are only rated for about 120. So it does pose a safety risk. Also adding to that, knowing that you have the properly rated digital multimeter is another important factor to play into this. So technicians may have a digital multimeter on hands. Typically, we find one that stateside, we call it Harbor Freight, but you can find a digital multimeter at Harbor Freight, but it may be rated incorrectly for the task at hand. So some of those are 400 volt ratings, maybe 600 volt, but typically we need, at least on Proterra buses, 800 volt or more. On top of that, your leads are another important aspect of this. So knowing how to inspect your leads, confirm that they are also rated for the task at hand. But just as importantly, we need to make sure that we know how to use our leads properly. So don't pierce through the insulation, understanding how to actually back probe and when it is appropriate to back probe without causing any damage to the circuit. Be it high voltage or low voltage, there's always the inherent risk of, if you back probe incorrectly, you can cause more work for yourself in the long run. Next slide.
Yeah, sure, James. We had a question came in regarding the PPE, and just is there key differences in the requirements or the standards between Canada or US, or is it a North American standard for most PPE?
For most PPE, it should be the same across the board. Both NFPA 70E and CSA Z462 were basically built in parallel. They're slightly different standards, but the standards of PPE are the same across the board. So if there's any requirement that you see in NFPA 70E, you'll see the same requirement in CSA Z462.
Okay, great, thanks.
So building on our tools discussion here, I also want to throw in the prerequisites for precision measuring instruments. It's not as common that technicians will need to use these, but it is a skill that they need to have. Megameters, milliometers, and torque wrenches. And then also I'd add maybe oscilloscope use as something that would be beneficial as well. So megameters, these are electric meters that measure very high resistance values by sending a high voltage signal into the object being tested. So typically this is used for testing a breakdown of isolation. It can be used to test the breakdown of the insulation in electric motors to determine whether or not they are about to fail, is probably the best way to describe them, where, you know, if they've kind of had that wear in their life where it's time to either rebuild if at all possible, or just simply replace. It's also important to understand that it is high voltage being used to test these measuring devices. So make sure that there are safety considerations that are being used when using a megameter, and that PPE is required. So you are going to need your high voltage rubber gloves when using a megameter. Milliometers are the next one, and these are high current, low voltage devices. They basically are used to check for low resistance in a circuit. We want the minimum resistance possible. And the reason that I have this listed is, again, when we're going back to the bus bar conversation of when I was talking about the right tools for the task at hand. If I were to go through and make a repair using those bus bars, and I were to test using a milliometer, if I had scored that bus bar when using the improper tool, there's a strong possibility that it will give me the incorrect readings for what the actual resistance value should be. Again, we want it to be pretty low. There are specific tolerances for things such as charging, for example. So when the BEB control circuitry is looking at these resistance values, if they are out of range, you may not be able to charge a bus or even enable high voltage, because it sees that there's a problem with that bus bar. It doesn't know that it's just simply scored, but it knows that the resistance value is outside of what the parameters are. So it will throw a flag and cause problems. It will add to your troubleshooting headaches. Adding to that, torque wrenches and how to properly use them are the next one here. So torque wrenches, if you over torque any of these bus bars, since I'm still on this topic here, that will increase the resistance value as well. So this is actually a great way for you to use that milliometer to confirm that your torque wrench, one, was properly calibrated. You have gone through and recently calibrated it. And on top of that, the torque value that you used was correct. So it's basically mixing the two of these to confirm your repair. And as I mentioned, oscilloscopes, they're not overly common, but the biggest reason that I do want to point these out is that if it comes down to it where you are working on a bit of a head scratcher for CAN diagnostics here, Oscilloscopes are a great tool to actually be able to come in, check what those signals are, make sure that the amplitude is where it needs to be, and then really just kind of drive home what the repair needs to be for that reason. So it's not that someone has to be, an electrical engineer to understand how to use their oscilloscope. It's just simply they need to understand how to use the tool to be able to get the readings and then confirm with maybe an electrical engineer, an OEM representative, such as any of our engineers at Proterra, or even someone at your transit agency. Next slide.
Thanks, James. I just wanted to, we had a question come in about the tools. So just for the folks on the line, during the purchase process, we do have a recommended set of tools with the required standards, et cetera, that we provide out to the customers. Many of them we do sell directly, but there is the ability to buy them via third party. Additionally, there's, and James, you can maybe talk a bit more to this, but there's a pre-launch meeting as well, where we start to set up the safety training that you're going to take on at this site when the buses get delivered. And in that call, that's ahead of the actual delivery of the bus as well, there will be that reiteration of here's some of the tools that you're going to need for success. So yeah, we sort of hammer it a couple times, but James, if I got that wrong, let me know. But I think that's should answer the question that came in.
No, that was perfect, Mike. And I would just add that usually I'm in on those conversations as well. So I try to also discuss what type of training will be supplied, at least for us, but also, again, these prerequisites. So what is it that your technicians should have and what they should understand as far as skills prior to actually launching?
Yeah, perfect.
So adding to the skills, one of the most important things here is schematic reading experience. They don't necessarily have to go through a class, but they should understand how to read the symbols and icons that are found in any of these schematics. They should understand how to trace power flow. So again, your source to ground or just the complete circuit, if it's a battery positive to a battery negative, and the loop. Understanding that this is the source of truth. This is essentially what we're looking at here is when I have a troubleshooting fault that I need, or I have a fault that I need to troubleshoot in this electrical circuit, how exactly am I going to determine where the circuit flows, what points of input and output exist, what components could be a failure, essentially the simple troubleshooting steps. And I like to use the example typically of multiplexing when discussing this as well. So in a very simple multiplexing circuit, there's an input that is sent to a controller. The output then sends the signal to either a component to, let's say, open a door. If the door does not open, and in that circuit itself, there's only, realistically, we're talking about 4 total components that could be a problem. It could be the door, it could be the door system, it could be the circuitry itself, or it could be the controller. I'd say the fourth on this could be considered the energy storage system. And the reason I want to point that out is just because that is considered a component. But realistically, if the door does not open, even though you are commanding it open, I would hope that a technician would understand that if the bus is off, that's probably not going to cause an output. That said, I can go into this circuit and I can determine, okay, well, I'm not seeing an output from the controller, and the only thing between the controller and the door, or the controller and the energy storage system in this case, would be the circuitry itself, so the wiring. So I'm almost guaranteed that it is a wiring issue. And then this would fall back on to using your digital multimeter to really understand how to troubleshoot that circuit. So things like isolating the circuit itself, ohming it out, so ringing it out, and using your multimeter to make sure that you actually have a complete path all the way back to its connection point. Also taking a look at this, one of the things that we run into commonly is basic computer skills are often lost on most technicians. I think just about everybody on the call would agree that the technician workforce is kind of aging out a little bit. We're struggling to really get new younger technicians into the workforce that really want to work on buses, let alone battery electric buses or anything else of that new technology. And for that reason, we also have a bit of inexperience with basic computer skills. Things such as troubleshooting why I cannot connect to the bus, something that may seem simple to the rest of us that are used to troubleshooting these kinds of things, but is really foreign to someone who has not commonly done this. Understanding how to navigate to and through the proper diagnostic software. So which diagnostic software do I need to use for which subsystem? With most of ours, at least Proterra, all of ours is we have one cumulative diagnostic tool. So it communicates with everything, but that's not the same for all OEMs. So really understanding how to use the computer and the diagnostic software to the best of their abilities is really, really helpful in helping the technicians troubleshoot. And then also interpreting various types of data. So a lot of these tools also will allow you to graph, similar to an oscilloscope, where you can take these signals, graph them out, and understand what this is telling you. So say I've had a drop off with voltage at a certain point, or I've had a CAN signal drop off while I'm driving down the road at 40 miles an hour. What exactly could be causing that? Could it be something like EMI, for example, and how exactly do I fix it? This is the type of data that technicians are going to need to look at going forward to really understand how to troubleshoot a bus, really to that nitty-gritty level. Next slide. Let's take a look at training now. So we've gone through the skills. We've talked about just about everything that a technician should have, the groundwork that they should have to really be able to succeed when transitioning and implementing BEBs. So once the BEBs get on site, if these are the skills that they have ready to go, my team can step in and really, really get them prepared, make them really comfortable when working on the buses, and then you should be more than ready to go as soon as we've gone through our entire curriculum. So taking a look at training, one of the first things that we recommend, obviously, is introduction to BEBs. So starting off, subsystems that are the same as those found on internal combustion engine or hybrid electric buses. Discussing this and bringing this up in an introduction to BEB program really helps the technician to feel grounded in their skills and abilities and their base level of knowledge. It helps to also deal with any apprehension ahead of time, because most BEBs, really, there's a lot of similarities, and there are a lot of things that are the same on the bus as there are on ICE and hybrid buses. So they really should be familiar with most of what they're about to see. Also includes similar subsystems, so things that are basically the same functionality. It has the same purpose, but maybe it's electrically driven. I like to use topics here such as air compressors, for example. So on most battery electric buses, air compressors are going to be electrically driven. They're still going to have the same purpose of, I need to fill the air system, the pneumatic system, with air. And to that point, the pneumatic system, for all intents and purposes, is exactly the same as you have seen on most transit vehicles, on ICE and hybrid buses. So that pneumatic system is very, very similar. There isn't much that changes other than, again, that air compressor. And then finally closing out with the things that are specifically different. And this is where I like to talk about the propulsion system. So now, instead of you having, an internal combustion engine, a large diesel motor, you now have a small traction motor and an inverter that drives that drive axle. They're really, outside of that, you're talking about replacing fuel tanks with an energy storage system, so the batteries. And those are the big drastic differences that you're looking at. There are some slight changes that pop up as well. Hey, Mike, Excel popped up.
Oh, geez. Yeah. Sorry. I was trying to answer a question on the side.
No problem. I didn't want to have anything that popped up that shouldn't have been there. So talking about the drastic changes, I would also include, I say drastic changes, they're really not, but the concept is still the same, even though it's a different component. And we're talking about things such as DC to DC converters and inverters here. So for the inverters, as I mentioned with the air compressor, that is going to be driven by an inverter that takes power off of the energy storage system, so the batteries, and then supplies AC power to that air compressor. For some power steering systems, Proterra specifically, we do use a high voltage power steering motor. So that also uses that inverter. To charge the low voltage batteries, because we still have 12 volt and 24 volt systems on these buses, we use a DC to DC converter. And so using DC to DC converter has the same principle as an alternator, but it's a different design. So I'd say it's drastically different in the sense that this is a new concept for a technician to understand, but when you're talking about how it actually relates to the concept of charging the batteries, they should understand that perfectly well.
Right,
Next
James, I
slide.
just wanted to jump in. We had a couple questions. So one was, what do we offer for standard training from Proterra? And I know it's between 84 and 92 hours, depending on the type of charger, I believe, but it falls in there. And then one of the other questions, and just on the training, we offer continued, upskilling and refreshers and other modules that you can prepay to have a sort of a quarterly or annually retraining program or continued education of the workforce. And one of the questions was, how large is your team, James?
My team, we are 7 total at this point. I have an open rec for an 8th person that we're bringing on board, including myself. So I have 2 technical trainers, one that is, again, an open rec. I have 2 operations trainers. I have an instructional designer or developer that has just a phenomenal background. He's worked with NASA. And then I also have a media developer, and this actually was a very important role for us to bring on board. The reason that we wanted to have a media developer was because we are trying to virtualize, if you will, a huge amount of training for us. We want to create some e-learning content, but more than anything, we also want to have short troubleshooting videos, demonstration videos, anything that can be accessible that will be really helpful for a technician. It can be anywhere between 2 minutes long and 30 minutes long for an overview of a subsystem. This includes things like lockout, tagout, battery replacement procedures, traction motor replacement procedures, and so on. So this media developer has a background in 3D as well as photography and videography, and that's their whole goal. That is basically the build out of the content there. So lots of good stuff that we offer.
Great, thanks, James. And I just want to confirm you can hear me. I had a comment that it was a little choppy. I just want to make sure you were all right.
Yeah, we can hear you. It's a little bit choppy though.
Okay. I might call in, but I'll keep going here.
Okay. So building into the training conversation here, the subsystem theory of operation, as I mentioned, there are some pretty big differences when we start looking at the changes between BEBs and internal combustion engines. So understanding how traction motors work is a very important concept here. Most traction motors that you're going to come across, I have yet to come across a DC traction motor on a BEB, but most of them, as far as BEBs in transit are going to be concerned, are going to be an AC design. So that means they have 3 separate coil windings that will supply an electromagnetic field. It's an alternating electromagnetic field to a rotor inside that traction motor. That rotor is going to be your output, essentially. That is connected to the output shaft, and then that will turn the drive axle. These kinds of concepts are things that technicians really need to understand. So a training program that at least sets the basis and helps them understand the theory of operation for all of these is really going to be important. Regenerative braking is another concept that some technicians already are familiar with. So we have things such as hybrid electric buses that already have regenerative braking systems built into it. But on a battery electric bus, it's extremely important to understand how that plays in and how that will extend the range, affect the range in general. Some of our buses, for example, especially the Edmonton ones, do have dual traction motors. So how is the regenerative braking affected if one of those traction motors fails and the other is still running? So if I were to leave this bus out in service, would I drain the batteries down faster because I only have one traction motor returning energy to the energy storage system? So those concepts are also important there. Inverters and converters, also rectifiers. So converters and rectifiers are very similar concepts here, but we're talking more about the idea of with inverters. So how do I take a DC voltage and turn it to an AC voltage? And then with the converters, how do I step up or step down DC and or AC voltage? So with the converters, again, we're talking about things like a DC to DC converter, where we take high voltage energy from the battery packs, the high voltage energy storage system, and then supply it to charge the low voltage system, the 12 and 24 volt system, and the low voltage batteries. Contactors are another important concept. It seems like they wouldn't need to be in some regard, but truthfully, understanding that those are considered high voltage relays is a concept that a technician should be familiar with. So how do I enable high voltage in a system? I supply a 12 or 24 volt signal to a coil winding inside of this contactor that then closes the contacts and closes the circuit, enabling high voltage to flow. Transformers, and no, we're not talking about Optimus Prime. We're discussing specifically step up and step down transformers, how they are used in a circuit. And keep in mind, the transformers don't have to be, large facility size transformers. They can be very small ones that are built into things like inverters. And then also one of the important ones to take a look at here is the high voltage interlock loop, so the HVIL. Importantly, with the HVIL, this is one of the it can be a bit of a troubleshooting headache if technicians don't understand how the HVILs work and how they're interconnected. But also to that point, it is meant to be a safety device. So it's not one that we ever recommend relying on. It is one, though, that we recommend paying attention to, because the whole point of the HVIL is if there is intrusion to high voltage componentry, for example, or if there is a break in the circuit that could lead to a shock hazard, arc flash hazard, a danger to any personnel, we want to break that circuit. We want to make sure that the HVIL causes the high voltage to be completely disabled. And this is something that a technician should understand going in, again, because it helps deal with the apprehension. So understanding how the HVIL works really gets them feeling confident and safe when starting to work on a VEB. Next slide. Also taking a look at this, as I mentioned before, OEMs, we're going to come in and we're going to give you our PMI training as well as the lockout tagout training. We're going to give you diagnostic training as well. There's a lot that really goes into this, but the most important topics, again, for technicians here are the lockout tagout procedures, so specific to that OEM, and then the preventative maintenance procedures, again, specific to that OEM. So with lockout tagout, how do I safely de-energize the bus? How to confirm that everything has been dropped, that there is the absence of voltage, how to keep others from inadvertently re-energizing the vehicle. So what types of lockout tagout devices do I need to use to make sure that something hasn't been re-energized? I purposely used this type of device here because this lockout tagout device is perfect for any of the PCS chargers. It is applicable to locking out our PCS chargers. However, we do not recommend using this on the vehicle. We actually recommend using a cable cinch lock multi-device so that the lockout switch, so our master disconnect switch, as well as the service switch at the high voltage junction box cannot ever be turned. You pull it tight enough that that switch can't be turned and re-enabled inadvertently. With this type of lockout device, there is a little bit of play in there. So obviously it would not be the right lockout device to make sure that nobody re-energizes the circuit. And then again, as I mentioned before with the HVIL, understanding the devices that are meant to keep technicians safe, drivers and passengers safe as well. So the reason that I include this is even though it is not part of the lockout tagout procedure, it is included in the high voltage safety conversation. So all OEMs should include that in their lockout tagout procedures, starting off with the high voltage safety conversation. We really need to make sure that we drive that home. OEM preventative maintenance, most of this is going to include your visual inspections, such as looking for burning, any signs of overheating, taking a look at the potential for broken torque marks, so indicating that maybe a fastener has backed itself off or maybe has been over torqued, for example. Failed fuses or circuit breakers, and then also taking a look at wear indicators, so things such as your brakes. Replacement of fluids is another important one here, so the intervals that are associated with replacing things such as coolant. Typically, it's about 100,000 miles, mostly because that is what is designated by the coolant manufacturers. And then functional checks as well. So is my air compressor working? Is the high voltage enabling? Are the brakes working properly? So all of this is going to go into PMI. Next slide. You're on mute. You're on mute, Mike.
Do we offer training when it's on a non-Proterra charger?
We do not offer training on a non-Proterra charger for a variety of reasons. Most importantly, though, the reason that we don't is typically because we sell chargers as well. Most of our competitors, so other people that are selling chargers, don't want to share that IP, and it's understandable. So we can help coordinate with that manufacturer to make sure that they are supplying the charger maintenance training for you. So the next, and I believe it's the one of the most important ones here that I want to point out. While it's not a requirement yet, there is a drive to have NFPA 70E or a CSA Z462 training for all BEB technicians. Eventually, we want to have this in place for everyone. It's going to enable the technicians to understand the differences in the arc flash hazard category ratings. So again, category rating 0 technically just means there's a shock hazard category versus arc flash hazard category rating 1 does require full arc flash gear. Now, the differences between those also means that there's a different calorie rating per arc flash suit. So you may have an 8 cal, 12 cal, 15 cal, 40 cal, and so on that come into play here. So understanding that and how that also plays into the incident energy calculations, not that a technician needs to do any of these calculations, but more being able to read what those incident energy calculations are, and then appropriately using the right arc flash hazard category associated with those calculations. So again, looking at that as well as the various levels of PPE required and the high voltage safety associated. So NFPA 70E, it covers that blanket introduction, but it also does cover a bit of just generic high voltage safety. What should you expect to do around AC circuits and DC circuits? There's a lot of really good information that's included here. And one thing that I do want to point out, we get a lot of questions about what kind of OSHA training, I guess is the best way to put this, is applicable for any BEBs. And what I usually respond with is NFPA 70E is actually driven by OSHA. So OSHA basically mandates through the NFPA that they build out this type of material, this type of safety training, and basically build this content and make it available for everyone. So if you're concerned about having the OSHA training, just know that NFPA is driven by OSHA. So you're kind of ticking off both boxes there.
James, another question, I'll try and get this one right, but how long does it take to de-energize a bus once locked out, tagged out?
So it really varies. So on our buses specifically, you can technically de-energize a bus within 5-10 minutes. We build in that 5 to 10 minute window solely for the fact that if there is a failed resistor circuit to bleed down any of the capacitors in the inverters, it's had time to discharge the capacitors. As long as the resistors and everything in there are working properly, you could have a bus locked out and de-energized in that 5 to 10 minute range. It's very quick for our inspection. Some other OEMs, it's a little bit longer because you have to go through and remove the MSDs or the manual safety devices from each individual energy storage system and then verify the absence of voltage. So it really just varies from design to design.
Great. Thanks.
Sure. You can jump to the next slide. So I also want to include in here that CAN and multiplexing theory and troubleshooting are extremely important. So CAN and multiplexing at their absolute base level are very similar theories. You're basically talking about sending a signal across the same lines to multiple devices. So the best analogy that I like to use here, and we use it in our training all the time, is if I'm directing this conversation to Mike and I say, hey, Mike, next slide. I would like him to change the next slide. Everyone here heard that message, but it was only applied to Mike, and he's the only node that's going to act on that message. So that is essentially what we're talking about with CAN and multiplexing. It's a very simple theory when you're looking at it. The designs are slightly different between them, and that is something to take into account here. So the actual physical design is something that the technician should understand as well, but the theory of operation is really important. And then also the troubleshooting aspect of it. So as I mentioned before, with troubleshooting, they may need to use an oscilloscope if they cannot use the diagnostic software to really get the information they need. And then another one that I include is also charging theory. So just very simple on the charging theory here, the charge rates based on the energy storage capacity and the output of the charger. And that's just usually a simple calculation of, let's say I have 440 kilowatt hours available on board for this battery, and I have a 60 kilowatt output. What exactly is my calculation going to be? from this charger to be able to charge up this bus. It's just as important for everyone in the back office and for supervisors and management personnel to know this when planning out routes and charging times. Also included in this would be based on battery chemistry. So the difference being lithium ion battery packs, for example, can only take a certain high power charge for a certain period of time, but lithium titanate, which is a variation of the lithium ion, actually has the ability to take in higher rates of charge, but they're limited on their output. So you may only get 80 kilowatt hours on board versus, again, the 440 that we're talking about. So pretty drastic differences there. And then the troubleshooting faults on the charger versus the bus. Now, this is probably going to be the biggest one that I want to make sure that I drive home here is charging theory. When we're talking about the troubleshooting aspect of it, there's always a fine line on whether or not this is something that a bus technician is going to be working on or fixing, or whether or not it's a charger technician. So maybe a facilities maintenance technician that we will be troubleshooting this. And again, the reason that I say that is because at a certain point you have to determine whether or not the fault exists on the charger or the bus or both. And so charging theory should help them understand where the delineation would be. Next slide.
No problem, James. And I've been called a lot worse than a gnome, so I'll take it.
Well, I didn't mean that as an insult, Mike. So, so I'd like to close out the training requirements here and say that most importantly, we also want to include our first and second responder training. So this is applicable to technicians, but it's also applicable to first and, again, second responders. Second responders could be the technicians that are on site, but also the people that are going to tow the vehicle away. They would be considered second responders in this case. The most important information they want to include is high voltage safety. So where it may be present, how to avoid cutting into any of these areas. Thermal runaway response. So what exactly happens if there is a battery fire? For most lithium ion, specifically for Proterra battery packs, I can definitely say to this, our procedures involve using a thermal imaging camera and spraying it with water. Lithium ion battery packs, our lithium ion battery packs can be sprayed with water safely without concern. We want to include areas of egress, cribbing locations, and then additional extraction points. So if there's a rollover or if if there's some sort of collapse on the canopy, for example, how do I continue to extract people? Where can I cut in? This kind of information is really important for first responders. For the second responders, we also want to make sure that they understand exactly how much time a battery may need to be isolated. So if we're transporting this bus to a wreck yard, for example, after a catastrophic collision, what do I need to be aware of and how do I need to transport it? So this is information that they will need to know as well. And then I always like to include high voltage refreshers. This really helps if you have technicians that may only encounter high voltage BEBs occasionally, especially if you have a transit agency where the unions cycle positions. This really comes into play. So a high voltage refresher will mitigate any apprehension that a technician may have when working around high voltage. It will familiarize them, but more importantly, it will also help prevent complacency. And that is probably the most important thing because from a rail car maintenance aspect, this is where we actually ran into more safety issues. So we would typically have, if you had complacency issues, that's when somebody was getting hurt. They weren't afraid or they weren't afraid to forget their PPE. They would kind of take shortcuts. These were things that they just, again, became complacent with. So we just want to make sure that they're following the same procedures that they're supposed to be following. Next slide. All right, so taking a look at crossover skills, and I may speed this up just a little bit since I think I've talked over a little bit, but I wanted to make sure that we at least take a look at these. Crossover skills is something that I like to talk about with preparing workforces as well for BEBs. Sourcing technicians with similar skills in the effort to reduce the amount of time to bring your technicians up to speed, your workforce up to speed. To start, hybrid vehicle technicians. The reason I say vehicles specifically and not just BEBs is it's still the same devices, it's the same subsystems, just larger or smaller skills or scales, excuse me. So they should already be familiar with generic lockout, tagout procedures, different safety devices. They should already be familiar with inverters, traction motors, energy storage systems. And then they should also understand the regenerative braking principles and procedures here. So hybrid vehicles are great, or hybrid vehicle technicians are a great place to start. Next slide. The next, and I like to bring this up given my own experience here, is actually light, medium, or heavy railcar, passenger railcar technicians. So my background, again, at WMATA, I was a railcar technician to start and then moved into training. And prior to that, I was automotive. And it turns out when you marry the two concepts, you basically get a battery electric bus. It's kind of strange how it worked out that way. But it works really well. And I can say from my experience in training with Proterra and building out this program that we have, really any technicians that have worked on rail cars that have transitioned over towards battery electric buses or just transit buses in general, they tend to have a leg up. They're already familiar with the theory. They understand heavy duty vehicles. They're familiar with the concept of high voltage contactors, for example. They're comfortable around it, and they just basically need to know the basics of how do these inverters work? What do you need me to replace? Where do I lock things out? And how do I remove power and so on? So there's a lot of really good information here. The biggest thing that I like to drive home, though, is that they are often the most proficient with schematics. Railcar technicians operate solely on schematic readings. So most of them will be coming from, at least electricians will be coming from background where they've worked with this most often. So they'll be the most proficient that you'll come across. Next slide. Now, one that may be a bit overlooked, but I found it is actually quite helpful is forklift technicians for a variety of reasons, especially when you're talking about forklift technicians that have worked with electric forklifts. They already have the same devices inside. They're familiar with chargers specifically and various types of chargers. They are familiar with hydraulics. They're familiar with pneumatics. They're familiar with various types of lockout, tagout, traction motors. So all of these skills that are basically required to be part of a BEB technician are also included with forklift technicians. And to that point, one of my instructors who is extremely skilled actually comes from a forklift background. I get all sorts of fun stories about forklifts, but he really, really knows what he's talking about when it comes to translating that information over. Next slide. Adding to that, facilities maintenance technicians. Now, with facilities maintenance technicians, they are likely going to be the ones that are going to be geared more towards chargers. They already have experience with chargers. But because of that, they're also going to understand high voltage, electrical theory, more usually on the AC side of things than the DC side of things, but it's not hard for them to translate that over. So they should have a really solid base, at least to be able to get them started. And then also on top of that, some facilities maintenance technicians, depending on the facility that they're working in, will have experience with heavy duty vehicles. So they'll feel comfortable working in that type of environment. Next slide. And then just a big one I kind of wanted to note here, identifying champions of EV. It can kind of take a little while to find the right rhythm to identify exactly who the champion is or who the champions are in your organization. But what we try and really say is foster them. If you come across anybody who is just interested, they don't have to be the most skilled person, but helping them get up to speed, really sending them for the training that they can use to be successful, and taking an interest in their interest is going to help your organization in the long run here. They're going to be the ones that will consistently talk up your BEB fleet. They're the ones that are going to help the technicians that maybe are apprehensive see a different picture. They're the ones that are likely going to take on the more difficult tasks or maybe the more difficult troubleshooting. So if you have the ability to be able to identify, and you do come across anybody who is definitely showing that type of interest, we recommend fostering that relationship and really helping them grow. Next slide. All right, so we're going to get into the charger infrastructure and familiarization here, talking about the solutions standards and safety. But before I get into that specifically, Mike, are there any lingering questions that we can kind of address now before switching over?
No, we've hit them all, James. That's great. And we've got 30 minutes left, so perfect.
Okay, I'll jump right into it then. Okay, so starting off with your depot solutions, these require installation of chargers in the bus barn or yard. So I know that because it gets cold in Canada in various locations, you're likely going to have a bus barn rather than a yard. In all of our US states, it can vary. So we have some outdoor storage as well as indoor storage. To that point, the upside of this means that there is no lease agreement that you have to worry about for on-route charging. So there can be a big upside to using these depot chargers. They also allow for off-peak charging, which can save you money in the long run. But do keep in mind that their output is typically limited. So if you're looking at your typical depot charger, which is also commonly called a plug-in charger here, the most of the output is going to be capable of is somewhere around 150 kW. Sometimes it will be derated. Sometimes we can do a little bit more if it's cooled properly, but those variants aren't exactly common yet. To that point, they're good for large fleets for continuous charging, but keep in mind that it does affect your grid. So if your grid, for example, here is not set up, you don't have a proper substation nearby to be able to power 1.5 megawatt charger with 40 dispensers hooked up to it, that is something you're going to have to take into account prior to actually implementing this type of charging system. Next slide.
Sure. A quick question, James. Someone asked, getting back to the training, have you seen a good fit with IT technicians that have crossed over?
I haven't encountered many is probably the best answer I can give.
Okay.
I've met some technicians that have had a background in that, but they are few and far between. I would say that given the computer skills point of that, it's worth exploring that. Absolutely.
Great.
So taking a look next at pantograph charging, this is also referred to as overhead charging. It can be installed anywhere really. So you have your depot charging option where you can install it in a bus barn, but it can also be installed on route. This is kind of what we call opportunity charging at the moment. So these overhead fast chargers, so DC fast chargers, allow for a higher output from the charger itself, allow for fast charging windows on the bus. Keep in mind that at a certain point, it does derate. So you're not going to be able to continuously output, let's say 500 kW to the bus at all times. There's a small window where that fits. Otherwise, it derates into a certain window where we're trying to prevent overheating of the batteries and any really damage or degradation of the battery cells. This does allow for reduced charge time, excuse me, since we're talking about more than 150 kW. And there are two typical types that you're going to come across. There's a third that's being validated, but it's still kind of going through the works here. Your design here, we have an inverted pantograph system where it's actually from the top down, plugs into the bus or connects to the bus there. Otherwise, we have the bus up option, which is, we'll show in a little bit here, but this is your typical of your J3105 standard. Next slide. Another option we have here is the inductive charging solution. Now, this is not as common in the industry yet. It is in the works. It's installed in ground, works very similarly to the charger on your phone. So if you have one of the newer iPhones, for example, and you use the inductive charging system where you just kind of lay it on a pad and it charges that phone. It's a very similar design. So in the bottom of a bus, there is a receiver. And in the ground itself, in the asphalt somewhere, there's a charge pad that creates an electromagnetic field that then charges the energy storage system on that bus. Like I said, it's still in development, so it's being refined a bit, but you may come across it. One of the biggest upsides to it that we've seen in the field really is that if you have tight spaces and a lot of storage or a lot of transit vehicles that need to be stored in a small storage area, and maybe you don't have enough room for multiple dispensers, this is a solution that various transit agencies have been exploring. Next slide.
Yeah, sure, James. Just jumping back to the pantograph, one of the questions that came in, is there an industry height requirement for pantograph chargers? I know typically our infrastructure team would work on a deployment for our buses with, strategic location and where that should be, but is there sort of a standard for height requirement with the pantograph charger?
I don't know of the height requirements specifically. I believe that is from design to design, but I can take a look at that and circle back. So if we can gather the information of the person that asked the question, I can look that up.
No problem.
So another aspect of this that we want to take a look at as well is there are two types of charging available besides the depot and overhead and in-ground charging. This is your AC versus DC charging. With DC, this is, we sometimes refer to it as DC fast charging, but that is also occasionally a misnomer depending on the system we're talking about. But the DC charging in this case is going through the charger itself. The charger then supplies or goes through either a step up or step down transformer and supplies that power to the energy storage system on the bus. And the bus is basically receiving a fuel up, if you will. The difference with an AC system is that you're actually supplying that AC signal. So very similar to a grid signal, maybe 240 or 480, depending on the grid and the design of the bus itself. But that AC system, that charger is typically on board. So there are upsides and downsides to this, mostly that the speed at which the AC charging system charges the batteries is often a lot slower than your DC charging system. The upside to it is it does require less equipment. The charger is on board for the vehicle. So if you're limited on space, that is something that you would want to explore. So again, there's upsides and downsides of these, and we're always happy to take a look and explore those with you. So if anybody has any questions about the comparison between the two, we can always, please feel free to reach out and, we'll discuss that offline. Next slide. So taking a look at the standards now, and this is the most important thing that I want to drive home for the different types of chargers. These are what are most common in North America. So we've got our J1772, which is your plug-in standard, J3068, which is your AC/DC standard, J3105, which is your overhead or pantograph options, and then J2954-2, which is inductive. J3068, we're going to take a quick look at because it's really not all that common in most transit applications. It's something that's been phased out, but it does exist in the market from time to time. So you may come across it, or some of your technicians may come across it. Next slide. So starting off with J1772, this is your DC fast charge in a transit application. This is what you're most commonly going to come across as your depot charger option. It does provide communications to and from the charger between the bus. There are 4 total levels. So this actually is capable of AC charging as well, or supplying an AC signal. This type of connection is. For AC, you have level 1, which is 1.4 to 1.92 kilowatts. And then level 2 is 19.2 kilowatts for AC charging. Level 1 for DC charging is 80 kilowatts, and then level 2 is rated for 400 kilowatts. But keep in mind that if it's rated for 400 kilowatts, there needs to be significant cooling. And then on top of that, the bus needs to be capable of receiving that amount. So typically, you're not going to come across a 400 kilowatt, even though it's rated that high. Next slide, please. So this is 3068. Again, this is not as common in North America. It has a very similar design. You can kind of see the plug on the left there is very similar to your 1772. It is considered a CCS design. So this is CCS type 2. You may come across it as a 3068. This does exist in the market. Again, just not very often. In single phase, it can supply up to 277 volts. I think that is a mistype on that side there for a single phase, but it can supply up to 277 volts AC. No, I'm sorry, that is a single phase. And then for 3 phase, 600 volts AC. This is centered more around that AC charging standard, but most transit vehicles do not have that at this time. Next slide. And then importantly, taking a look at our pantograph charging solution. So for the 3105, this is your roof mounted bus up, or and then we also have inverted, which is the bus down. Both of these are able to be installed on route or in the bus yard or bus barn. Edmonton is a great example of this. Their new garage that we showed early on also has that inverted pantograph option. That is one of the most commons right now, or common designs right now. The roof mounted option will go directly up from the bus and connect to, as you can see, it's kind of the shield. It's this A-frame that is on the roof, or the overhead gantry system. Just keep in mind that that does add weight to the bus, and adding weight to the bus can also affect the range. So the heavier the bus, the less the efficiency is. And so that is something to keep in mind when considering these options for charging. Next slide. And then quickly taking a look at J2954-2, this is your in-ground charging system. Like I said, it is an emerging technology. You can install it on route. You can also do depot charging options as well. And like I said, it's very similar to how your charging system works on your phones, where you just simply are over top of a transmitter that then is changing the electromagnetic field underneath of the receiver that then supplies a signal to the energy storage system charging it. Next slide. So taking a look at the basics for charger safety. To start off, this might seem like very common information, and truthfully it is, but I just want to make sure that we discuss this here. So always disconnect all input and output sources. Make sure that you're using proper caution before opening or working on any equipment. So for any charging, whether it be your depot charger, your overhead fast charging system, an inductive charger, all of this is going to require the same thing. Make sure that you verify the absence of voltage with a proper measurement instrument before servicing the equipment. So test before you touch. We always emphasize that saying. So test before you touch, but you also want to make sure that you're using the right digital multimeter. So if you have something that is, again, rated at 400 volts as a digital multimeter, it's not appropriate for an 800 volt system. So you're going to have to make sure you've got the right meter for the task at hand. To that point, as I had mentioned before, and I believe it was a question that we answered, was the DC capacitors, or on our buses, the inverter capacitors do hold a charge for a certain period of time. Just like in the bus, chargers have DC link capacitors that are tied in, and this also will hold a charge for a certain period of time. So again, we say for most chargers on our charging systems, 10-15 minutes is a good rule of thumb. Typically, by the time that you have locked out the input source and you've put on your arc flash gear, it's about safe to open up the charger and then start verifying the absence of voltage. Next slide. And just a reminder, because it's often overlooked, always make sure that you remove your jewelry, any watches, rings, metal objects before working on any high voltage equipment. The last thing that you want is an easy source for the energy to transfer to you and then down and out to the ground. Always use any anti-static wrist straps if you're working on any of the electronic equipment. So the circuit board specifically, this is kind of an important one because you're not working on a surface that is anti-static in nature, and because you're typically wearing EH-rated safety shoes and not static discharge safety shoes. There is a possibility of affecting those printed circuit boards. So you really want to make sure that you take those special precautions. And then finally, be sure that all electrical connections and connectors are properly installed and torqued. And the reason that I say that is with most chargers, they go through significant heating and cooling cycles on a regular basis. So think of this just along the lines of expansion and retraction. So as these connectors and these fasteners continue to expand and retract back to their normal size, there's always the possibility they'll loosen up, or a connector will back off from its properly seated position. So if a technician's going in and doing any sort of visual inspection, I usually tell them, as long as the device has been locked out entirely, you've confirmed there's no voltage, do your test touch on all of the connectors and make sure that everything is properly seated. Next slide. All right, so we're going to take a look at the lockout tagout procedures. And like I said, I'll go through this relatively quickly, so we still have a few minutes for question and answer at the end. But keep in mind, these are generic in nature. Some of this is built around ours, but as far as lockout tagout is concerned, this will always follow some paths similar to this. So starting off with a PPE, the required PPE, you're going to need an arc flash suit properly rated for the charger at hand. You're going to need an arc flash face shield and a hard hat or a hood, depending on the level of charger that you're working on. Balaclava and arc flash hood is also going to be required. Again, you're going to have to, it's going to be dependent on what you're working on. But a balaclava, for those unfamiliar, it's that white hood that the technician shown here is wearing. Safety glasses are a requirement. Earplugs is something that's often overlooked, but it is a requirement because an arc flash is very loud. It has the energy to essentially create a sonic boom in front of the technician. So it can cause significant hearing damage if that does happen. We want to make sure we protect the technician. Rubber insulating gloves with leather overlays. So they need to be appropriately rated as well. I believe for ours, it's class 0. Others may require significantly higher ratings, class 1, and so on. EH-rated safety shoes are the most important one here that I want to emphasize as well. It's not the most important, really your entire arc flash suit is, but the EH-rated safety shoes are very important. There's a difference between EH and SD. EH is electrical hazard, they're insulating. SD is static discharge, meaning that they're grounding. And the last thing you want, again, with the jewelry here, is a path for ground through the technician or through the person working on that charger. So just make sure they have the properly rated safety shoes. Next slide. Taking a look at the tools. Now, while these are not considered PPE, they are important for the task at hand here. These are the proper tools for the job. Appropriately rated DMM needs to be the proper digital multimeter. You need to have the appropriate lockout tagout devices. This is going to be something for the breaker itself, whether it be just a simple circuit breaker or whether it be an actual switch box. You need to have the appropriate lockout device for that. You need to have a lockout device for the charger itself. That will be dictated by the procedures. You're going to need to have one for the dispenser, again, dictated by the procedures. This also includes what's shown here as the lockout bag. So make sure that you're putting that CCS cable, if you're working on a depot charging system, in that bag so that nobody can plug the CCS cable into the bus, thereby creating another path towards potential energy, which is your ESS or energy storage system. Also make sure that you have your anti-static wrist strap. Again, I know that this isn't necessarily for lockout tagout, but if you're working in lockout tagout, it's good to have that on hand. So to start out, make sure that you disconnect the input, the AC side of things, make sure that you lock it out. So the switch gear itself or the circuit breaker needs to be shut off and locked out. Apply a lock and tag explaining the person that's working on it and what's being done. Disconnect the load or the vehicle from the charger. So again, we want to make sure that the ESS does not backfeed into the charging system as you're working inside of the charger. Inspect your PPE and tools and then gear up. So make sure that there's no damage to the rubber gloves. Make sure that all of your tools are in proper working condition. Make sure that your multimeter works properly. So measure it against a known good voltage source and then gear up properly. Confirm the recommended amount of time has passed. So wait that 10 to 15 minutes for the DC link to discharge and then go ahead and open the charging system. Next slide. Do your live dead live. So again, make sure that you're checking again against a good known voltage source, confirming that the meter is live. Do your dead test, which is examining both the DC and AC sides of the circuit inside the charger, confirming the absence of voltage, and then do a live test again, which means go back to the known good voltage source prior, and then make sure that you've got the same or at least a very, very close reading as you did before. After confirming the absence of voltage, you can transition down. Now, we had talked about this before, different levels of PPE required for different levels of maintenance. Now that you've confirmed there's no voltage present, you can step down the required level of PPE and do the work that needs to be done. Before re-energizing, make sure that all the covers are closed. And then once everything is closed and you've locked everything down, everything's back in normal working order just before that point, when you're about to re-energize, you're going to need to make sure that you have all of your PPE on board again, on your person again, just to make sure that there are no potential arc flash hazard events that happen as you re-energize. So a lot of information, and I hope really everyone enjoyed the conversation here. By now, you should understand how to best prepare your technicians, For success as you transition to BEBs, you should be familiar with the high voltage safety, the associated tools, all the PPE, and the best safety practices associated with high voltage safety itself. And then you should also recognize the various types of charging infrastructure and the associated safety procedures and precautions with it. So with that, I'd like to open the floor up to any questions, anything that might be lingering.
Thank you very much, James. So we'll just end. We know definitely as teams get back to going and agencies are opening up and workforces are coming back into the workplace and with the battery electric bus push and zero emissions for that matter, we're bringing more people back into the workplace. Obviously, as you identified early on, having a champion is key, sort of that whole mentorship of skills, et cetera, and having someone in place. So, you know, and I've, as many of you know, I've spoken a lot about mentorship and kindness in other realms, but just to remind everybody that, you know, to be patient, to be kind, you know, learning to enhance those skills and the confidence to continue to do that. Make kindness a priority in the workplace when you're training, you know, be that mentor you wish you had. And definitely, you know, we all make mistakes and education makes us all better. So James, thanks for an amazing presentation, as always. Always a pleasure to be on them. One day I'll learn something, so keep trying. I really appreciate it. Yeah, we don't have any questions that are lingered. We knocked them all off. So if anybody wants to, you know, fire questions internally to either Karen or to myself, most of you have my contact information as well. We're happy to readdress things after, and I can tie James in. But James, thank you for everything. That was great. And I know there was a lot of information. There was some questions about, will we make some slides available? We will definitely get sanitized. We just got to get it through our marketing department and get sign off, and we'll have something that Karen can distribute or have on the Optus site as well. So thanks everybody for listening. Really appreciate it. And with that, I'm going to turn it back over to Karen for a moment.
Well, thank you, Mike and James. I've been getting emails and comments. Great presentation. Lots of information that people needed. We have been recording this webinar today, and we will notify everyone when that is available and posted to the Opta website. So with that, thank you again to Proterra for sponsoring, and we hope everyone has a great day. Thank you.
Thanks, everyone.
Thank you.
James.